Welcome back to the Unit 4 notes. Today we're going to do Unit 4 Day 3. This is going over the three main periodic trends that you'll need to memorize for your test. The first one is going to be atomic radius. I just realized it wasn't there. Atomic radius, okay? Atomic radius is the distance between an atom's nucleus and its valence electrons. So just like how you would see the center of a circle to the outermost point of the circle, it's the same idea from what you learned in geometry. You go from the center of your atom to the outermost point of your atom. All right? And we're going to go ahead and highlight that definition so that you have it. Okay, the vertical pattern, which means a pattern that goes up and down, means as you go down a group, the atom's radius gets larger. This is obvious because you're adding an extra energy level every time you go down a period. Down to the next period. Okay, so if I'm looking over here, I have, as I go down a group, my number of energy levels increases. Okay, my largest atom is actually FR, Big Fat Ant Franny. So you can go ahead and highlight that so that you have it memorized. The closer you get to that element, the bigger your atom is going to be. Okay, my horizontal pattern, which is from left to right, atoms will get larger as I move from to the left across a period. So as I'm going from the right to the left, I am increasing the size. Okay, so all the elements in the same period, which is my row, have the same number of energy levels, but the number of protons in the nucleus will change. So the more positive protons I have, the closer it's going to hold those electrons in. So as I move towards my halogens and my noble gases, I'm really pulling in those outer valence electrons. So it's holding it closer, that way they don't leave. All right, so we're going to draw that on this periodic table. As I increase going across this direction and going down. So that Big Fat Ant Franny, it's francium, is my largest element. We're going to make a little note right here that francium is my largest element. Okay, I also want to make a little note over here that if I have fewer protons, which are your positive, means my electrons which are negatives, are loosely held. This gives us a big atom. So fewer protons is a big atom. Whereas if I have more protons, which again are those positives in my nucleus, means my electrons, which are your negatives, are tightly held. So that gives me a small atom. Whoa. So more protons, small atom. Okay, so let's do an example. I have calcium, strontium, magnesium, and beryllium. We're going to go ahead and drop those on this periodic table so you can see. We have calcium, strontium, magnesium, and beryllium. And I want to tell which one is, increasing to be the biggest size. So big is at this end, small is at this end. Okay, the closer I get to francium, the bigger it gets. So strontium is my biggest one. The further away I am, the smaller I am. So beryllium is the smallest one. And then you just fill in as I move up the group. As I move up the group, I get smaller. Okay, so then you're going to try number 2. Okay, my next pattern that I need to memorize is ionization energy. Okay, ionization energy is like all eyes on me. I want to know, or I want to keep my electrons on me. It is the amount of attraction an atom has for its own elements. So think of it as the energy required to move an electron away from the atom, to remove an electron from the atom. So a metal is happy to give away its electrons. It doesn't take much energy to do it, whereas your non-metals do not want to give away their valence electrons. So let's highlight the important parts. The definition of ionization energy is the amount of attraction an atom has. Your metals will give away. Your non-metals want to gain electrons. Okay, so let's put it on our periodic table. I increase going to my noble gases because my noble gases really don't want to give away those valence electrons. So I increase moving from left to right, and I increase going up a group. So that means helium has the largest ionization energy. So again, think of it like all eyes on me. I want to keep my electrons on me. And the biggest one is helium. So let's make our little note. Helium has the highest ionization energy. All right, so let's do this as our little practice. All right, I'm looking at number 1 down here. I have silicon, tin, lead, and germanium. And those are going to be, where's it at? Silicon is here. Tin is down here. Lead is here. And germanium is here. So as I increase going towards helium, the higher ones up here have more ionization energy. Whereas down here, I have a much lower ionization energy. So the one that's the highest will go here. The one that's the lowest will go here. My highest ionization energy is going to be that silicon. Up next is germanium. Then I have tin and then lead. All right, and then number 2, you're going to try. All right, the next one I have is electronegativity. Okay, electronegativity is the ability to, I want purple. To attract electrons in a chemical bond. So think of it as how badly it wants an additional electron. Okay? It wants an additional electron. So fluorine is my most electronegative element. So it's going to be a violent reaction whenever it bonds with something. It almost has 8 valence electrons, and it really wants 1 more electron. Okay, so if you offer up that 1 electron, it will greedily rip it away from you. Okay, your noble gases have virtually no electronegativity. That's because they already have 8 valence electrons. So they